Okay, in example 2, it says, given the parent function y equals log base 10 of x, state the equation of the function that results from each of the following transformations. And so you can see that there's a bunch of transformations given here, and your goal is to try to write the equation of the transformed function. So first part says vertical compression by a factor of a quarter. I know that'll affect the value of A. A horizontal translation right 5 units. I know this is going to affect the value of D. Vertical translation up 10 units, we know this is going to affect the value of C, and a reflection in the y-axis, so that's going this way, so left and right, so that is going to affect the value of K. And so if I write the transformed function here, I get f of x equals 1/4 log base 10 of negative x minus 5, since it's moving to the right 5, and then plus 10. Okay, so there's the transformed function there. Okay, for example 3, we're given the following logarithmic function. H of x equals 2 log base 2 of negative 3x minus 6, and then plus 4. Part A asks us to sketch a graph of h of x, and part B asks us to state the domain and range of h of x. So before we can actually sketch the graph of h of x, first thing we need to do is factor out the value of k. So I get h of x equals 2 log base 2 of negative 3x plus 2, and then plus 4. And what you'll notice here is that the first thing I need to identify is what my base graph is, and I've already done that down here. So the base function is y equals log base 2 of x. Okay, and you can see that because it tells me that the base of the logarithm is 2. And then I need to figure out what the vertical asymptote is. So the vertical asymptote is dependent on the horizontal shift left or right. And I can see that there's a horizontal shift to the left too, so I know that the vertical asymptote is x equals negative 2. Now before I do anything else, I'm actually going to sketch the vertical asymptote at x equal to negative 2. And so what this will help me create is a barrier for the logarithmic function. Okay, so I have an asymptote at x equal to negative 2. Okay, now from here what I'm going to do is figure out where my key points are. And so because the logarithmic function has a base of 2, what I'm looking for is 2 to the exponent 0. That'll give me the x coordinate, so that's 1. And then 2 to the exponent 1, which will give me the x coordinate again, and that's equal to 2. Okay, so I have my key points at 1 and 0, and 2 and 1. Okay, using the transformations from the function above, I can actually figure out the mapping formula for x and y. So I have reflection in the y-axis, compression by a factor of 3, and then a shift to the left 2 units. Vertically, I have a stretch by a factor of 2, and then a shift up 4 units. So if I plug in my x coordinates into the mapping formula, I can figure out my new transformed points. So I have a point at negative 2.33 roughly, and at negative 2.66 roughly. And then for my y coordinates, 2 times 0 is 0, plus 4 is 4, 2 times 1 is 2, plus 4 is 6. And so now I'll plot those points. Now I have a point at negative 2.33 and 4. So that's about there. And then I have another point at negative 2.66 and 6. So that's about there. And so you can see that the point that's closest to the asymptote is the one in which the direction of the graph is getting closer to the asymptote, and the point that's farther away from the asymptote is the one that keeps moving further away. So it's sort of doing something like that. It's not the best graph, but you get the idea. Okay, and so this is the graph of h of x. Okay, and then finally the last part of the question asks us to state the domain and range. Okay, in the domain of the function, you can see that the graph is to the left of the asymptote. That happened because there was a horizontal reflection along the y-axis. So you can see that the graph is to the left of the asymptote. So all the values of x that we have are less than negative 2. Okay, so all real numbers for a domain such that x has to be less than negative 2. In terms of the range, the graph will go forever upwards and downwards. So the range is all real numbers. Okay, and that's how you graph a logarithmic function.